Grounding and bonding are essential for electrical safety, especially when dealing with systems operating at 600 volts or higher. However, information regarding the specific height requirements for fences protecting such equipment is not available. These requirements are typically governed by local codes, utility regulations, and the National Electrical Code, specifically Article 110.31 regarding enclosure of equipment for installations of voltages more than 600 volts nominal. It is important to consult these resources to determine the correct height for a fence in your area. Factors influencing the fence height might include the voltage level of the equipment, the proximity to public access areas, and the type of equipment being protected. Some electrical codes state that a fence needs to be at least 7 feet high. Some utilities require an 8-foot fence. It is also important to check with your local utility company to see if they have additional requirements. Regarding the placement of a 3-way switch in a stairwell, the number of risers is relevant for determining the optimal switch location. Generally, a 3-way switch is placed at the top and bottom of a staircase to allow for convenient control of lighting from either end. A common approach is to locate the switches such that they are easily accessible upon entering the stairwell from either the top or the bottom. With 6 risers, this means the switches will ideally be placed before the first step at the bottom and after the last step at the top. This allows a person to turn on the light before entering the staircase and turn it off after exiting. The purpose of a 3-way switch is to control light from 2 different locations. This is achieved using a pair of 3-way switches, each with a common terminal, Traveler Terminal 1 and Traveler Terminal 2. The common terminal of each switch is connected to the power source or the light fixture. The Traveler terminals are connected to each other via 2 Traveler wires. The operation of a 3-way switch can be understood by considering the different switch positions. When both switches are in the same position, the circuit is either open or closed, depending on the initial state. When either switch is flipped, the circuit changes state, turning the light on or off. To properly wire a 3-way switch, firstly, turn off the power at the circuit breaker. Secondly, identify the wires connected to the existing switch. Thirdly, connect the common wire to the common terminal of the new 3-way switch. Fourthly, connect the Traveler wires to the Traveler terminals of the new 3-way switch. Fifthly, repeat steps 3 and 4 for the second 3-way switch at the other location. Sixthly, turn the power back on at the circuit breaker and test the switches to ensure they are working properly. It is important to follow electrical codes and safety precautions when working with electrical wiring. If you are not comfortable working with electricity, it is best to hire a qualified electrician. The neutral wire is typically white or grey and is connected to the neutral busbar in the electrical panel. The ground wire is typically green or bare copper and is connected to the grounding busbar in the electrical panel. Always consult the latest edition of the National Electrical Code and local building codes for specific requirements and regulations regarding electrical installations. These codes provide detailed guidelines for safe and compliant wiring practices. Remember, electrical work can be dangerous if not performed correctly. If you have any doubts or concerns, seek assistance from a qualified electrician. Always prioritize safety when working with electricity. Before beginning any electrical work, turn off the power at the circuit breaker or fuse box. Use appropriate safety equipment, such as insulated gloves and safety glasses. Double-check all wiring connections before restoring power. If you encounter any unexpected problems or are unsure about any aspect of the electrical work, stop and consult a qualified electrician. It is better to be safe than sorry when dealing with electricity. The grounding system is an essential part of any electrical installation. It provides a path for fault current to flow back to the source, allowing the circuit breaker or fuse to trip and to energize the circuit. A properly installed grounding system helps to protect against electric shock and fire hazards. The grounding electrode system typically consists of a ground rod, ground plate, or other approved grounding electrode that is connected to the grounding busbar in the electrical panel. The size and type of grounding electrode required depends on the size of the electrical service and local code requirements. In addition to the grounding electrode system, all metallic enclosures such as electrical panels, junction boxes, and equipment cabinets must be bonded together to create a continuous grounding path. Bonding jumpers are used to connect these enclosures to the grounding busbar. The size of the bonding jumpers must be appropriate for the size of the circuit conductors. Proper grounding and bonding are essential for electrical safety. A poorly grounded or bonded system can create a dangerous shock hazard. If you have any concerns about the grounding system in your home or building, consult a qualified electrician. Remember, electrical work should only be performed by qualified individuals who are familiar with electrical codes and safety practices. The overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When the current in a circuit exceeds the rated capacity of the circuit breaker or fuse, the device will trip or blow, interrupting the flow of current. Circuit breakers are reusable devices that can be reset after they trip. Fuses are single-use devices that must be replaced after they blow. The size of the circuit breaker or fuse must be appropriate for the size of the circuit conductors and the load being served. Using an undersized overcurrent protection device can cause nuisance tripping, while using an oversized device can create a fire hazard. It is important to select the correct overcurrent protection device for each circuit. The National Electrical Code provides detailed guidelines for selecting overcurrent protection devices. The NEC Table 310.15b16 specifies the allowable ampacities of insulated conductors rated up to and including 2000 volts. The table provides ampacity values for different conductor sizes, insulation types, and installation conditions. It is important to consult this table when selecting conductors for electrical circuits. The ampacity of a conductor is the maximum amount of current that the conductor can safely carry without overheating. The ampacity of a conductor depends on several factors, including the conductor size, insulation type, installation method, and ambient temperature. When selecting conductors for electrical circuits, it is important to choose conductors that have an ampacity that is sufficient to carry the load being served. The conductors should also be protected by an overcurrent protection device that is sized appropriately for the conductor ampacity. The NEC Article 250 covers the requirements for grounding and bonding electrical systems. This article provides detailed guidelines for ensuring that electrical systems are properly grounded and bonded to protect against electric shock and fire hazards. The NEC Article 250.45 requires that all exposed non-current carrying metal parts of electrical equipment be bonded together and connected to the grounding electrode system. This requirement helps to ensure that any fault current will flow back to the source, allowing the circuit breaker or fuse to trip and to energize the circuit. The NEC Article 250.118 lists the acceptable methods for grounding and bonding electrical equipment. These methods include using grounding conductors, metal raceways, and other approved means. It is important to follow the requirements of NEC Article 250 when grounding and bonding electrical systems. The NEC Article 300 covers the general requirements for wiring methods. This article provides guidelines for installing electrical wiring in a safe and compliant manner. The NEC Article 300.4d requires that conductors be protected from physical damage where they pass through metal framing members. This requirement helps to prevent damage to the conductors from sharp edges or other hazards. The NEC Article 300.11 requires that raceways and cable assemblies be securely supported. This requirement helps to prevent the raceways and cable assemblies from sagging or becoming damaged. It is important to follow the requirements of NEC Article 300 when installing electrical wiring. The NEC Article 408 covers the requirements for switchboards and panel boards. This article provides guidelines for installing and maintaining switchboards and panel boards in a safe and compliant manner. The NEC Article 408.3e requires that all switchboards and panel boards be clearly marked with their voltage rating and ampere rating. This requirement helps to ensure that the equipment is used within its rated capacity. The NEC Article 408.36 requires that all overcurrent protection devices in switchboards and panel boards be readily accessible. This requirement helps to ensure that the overcurrent protection devices can be easily reset or replaced when necessary. It is important to follow the requirements of NEC Article 408 when installing and maintaining switchboards and panel boards. The NEC Article 517 covers the requirements for healthcare facilities. This article provides guidelines for installing and maintaining electrical systems in healthcare facilities in a safe and compliant manner. The NEC Article 517.13 requires that all electrical equipment in patient care areas be grounded to a common grounding point. This requirement helps to minimize the risk of electric shock to patients. The NEC Article 517.16 requires that all critical care areas be provided with an isolated power system. This system helps to protect patients from electric shock in the event of a ground fault. It is important to follow the requirements of NEC Article 517 when installing and maintaining electrical systems in healthcare facilities. The NEC Article 547 covers the requirements for agricultural buildings. This article provides guidelines for installing and maintaining electrical systems in agricultural buildings in a safe and compliant manner. The NEC Article 547.5 requires that all electrical equipment in agricultural buildings be suitable for the wet and corrosive environment. This requirement helps to prevent corrosion and premature failure of the equipment. The NEC Article 547.8 requires that all wiring in agricultural buildings be protected from physical damage. This requirement helps to prevent damage to the wiring from animals, equipment, and other hazards. It is important to follow the requirements of NEC Article 547 when installing and maintaining electrical systems in agricultural buildings. The NEC Article 600 covers the requirements for electric signs and outline lighting. This article provides guidelines for installing and maintaining electric signs and outline lighting in a safe and compliant manner. The NEC Article 600.6 requires that all electric signs and outline lighting be listed and labeled. This requirement helps to ensure that the equipment has been tested and certified to meet safety standards. The NEC Article 600.9 requires that all electric signs and outline lighting be installed in accordance with the manufacturer's instructions. This requirement helps to ensure that the equipment is installed correctly and safely. It is important to follow the requirements of NEC Article 600 when installing and maintaining electric signs and outline lighting. The NEC Article 625 covers the requirements for electric vehicle charging systems. This article provides guidelines for installing and maintaining electric vehicle charging systems in a safe and compliant manner. The NEC Article 625.15 requires that all electric vehicle charging systems be protected by a ground fault circuit interrupter. This requirement helps to protect against electric shock in the event of a ground fault. The NEC Article 625.22 requires that all electric vehicle charging systems be installed in accordance with the manufacturer's instructions. This requirement helps to ensure that the equipment is installed correctly and safely. It is important to follow the requirements of NEC Article 625 when installing and maintaining electric vehicle charging systems. The NEC Article 680 covers the requirements for swimming pools, fountains, and similar installations. This article provides guidelines for installing and maintaining electrical systems in these locations in a safe and compliant manner. The NEC Article 680.26 requires that all metallic parts of swimming pools, fountains, and similar installations be bonded together. This requirement helps to minimize the risk of electric shock to people in or around the water. The NEC Article 680.42 requires that all electrical equipment within a certain distance of a swimming pool, fountain, or similar installation be ground fault circuit interrupter protected. This requirement helps to protect against electric shock in the event of a ground fault. It is important to follow the requirements of NEC Article 680 when installing and maintaining electrical systems in swimming pools, fountains, and similar installations. Remember that compliance with the NEC is crucial for ensuring the safety of electrical installations. Always consult the latest edition of the NEC and local building codes for specific requirements and regulations. When it comes to fence height for the power equipment, contacting the local utility and code enforcement office is a must to avoid any penalties, fines, or safety violations.